Welcome to the video about circumference and arc length. Okay, so for bell work purposes, we're going to recap on things such as inscribed angles and circumscribed circles. Okay, so let's go ahead and view this. Again, I'm going to try to do this alphabetically, so I'm going to find W first. And W, if you pay attention, is an inscribed angle. So W is equal to the sum of these. And again, if I'm doing an inscribed angle, it is half of the arc itself. So I have 95 plus that 45, and I'm going to divide that by 2. Okay. 95 plus 45 is 140. I'm going to divide that by 2, which tells me that W is then 70. Okay. Next in the alphabet there is the value of x, so x equals. Again, we have an inscribed angle, so we have these two angles, these two intercepted arcs that make up that angle. Okay, so if we extend these out, we have this one and this one. So I have 90 plus the 45 divided by 2, which gives me 135 over 2. Which is not as nice as this. So that gives me 67.5. Okay, again, with something like that, I would take 135 over 2 because that is a simplified and reduced improper fraction. Okay, next to find the value of y. So y, now we use that the circumscribed angles here. And we notice that w and y are opposite of each other, so therefore they are supplementary. So then y is equal to 180 minus the value of w. So minus the 70, which tells me it's 110. And likewise with angle z here, if I look at z and x, those are opposite of each other. So z is equal to 180 minus angle x, which was the 67.5, which gives me 112.5. Okay. Number 2, in a similar situation here, we have x. And this is an inscribed angle, so I can go back out to my intercepted arc here. I can add these two together and divide by 2, so 110 plus the 112 over 2, which tells me that 222 divided by 2, which is 111, is the value of x. Okay. And because this one has z as opposite of it, I'm going to go ahead and find z next. So z, again, falls into that opposite angles add up to 180 category. So 180 minus the value of x, which was the 111, which tells me that z is then 69. With y, we have the two expressions, so I can combine those expressions, which tells me that 2y plus 3y plus 5 equals 180. I can again combine the like terms to the left-hand side, so I have 5y plus 5 equals 180. I can subtract 5 then from both sides. That gives me 5y equals 175. If I divide by 5, then y is 35. Okay. Moving on to the content. Again, just a review of circumference. Circumference has two possible equations we can look at and analyze. Circumference is essentially the perimeter of a circle. So if I take and I stand on the outside of that circle and I just walk around it, how far distance-wise did I travel? Okay. How do you find circumference? Again, we have two possible equations. C equals 2 times pi times the radius, or C equals pi times the diameter. Okay, and again, diameter with relation to radius, the diameter equals 2 times the radius, which is why the equations are equivalent. Okay, so 3 examples here. Again, it's just using the basic equation itself. All we're going to do is we're going to pick which equation to work with. Okay, and you should be able to figure that out because in the problem itself, it's going to give you a keyword. That keyword is going to be the word radius or diameter. So if you pay attention here, this is radius. This one says radius. This one says diameter. Okay, so because they say radius and diameter, that's going to tell us which equation to use. Again, we have 2 equations. C equals 2 pi r. If we're given the radius, then we would use that one. We also have pi times the diameter, or pi d. So if we give the diameter, or we're looking for the diameter, then we're going to use the one that says pi d. Okay, so don't make this overly complicated. Pick the right one. Number 1, again, says the radius is 20 centimeters or 20 inches, and I'm looking for the circumference. So C equals 2 pi r. And we're just going to plug in. C equals 2 times pi times the 20. And I'm going to make life real simplistic here. I like the values to be as holistic as possible. So if we can leave pi in the problem, I'm going to have you do so. Okay? So 2 times 20 is 40. And then I'm just going to attach that pi symbol right there next to it and call it a day. Okay, so the answer here would be 40 pi. Okay, number 2 is a similar situation. So it gives radius. So I'm going to use C equals 2 pi r. But now notice that it says the circumference is 42. So 42 is going to be plugged in here for C. 2 pi r is then going to follow down. And to simplify and solve for r, I'm going to have to divide both sides by 2 pi, okay, because that's what's attached to the r. When you divide by 2 pi, these will cancel, and that will leave me with r is equal to 42 over 2 pi. Please note that you will possibly have to reduce a little bit further. So like here, 42 and 2 are both even numbers, and therefore can be divided by 2. So if I divide the top and the bottom by 2, that gives me 21 over pi. And again, I'm just going to leave pi in the answer. I don't want to put 3.14. I don't want to put any other decimal expansion. I don't want you to hit the pi key on the calculator. I want you to just leave pi. Okay. Number 3, find the diameter of the circle with a circumference of 25 centimeters. So here, again, I'm using the word diameters, which means I'm going to have C equals pi times d now. Okay. Different equation, same value, right? Again, I just give you the diameter instead of the radius, or vice versa. So here I'm going to plug in what I know. Circumference is 25. So 25 equals pi times the diameter. And again, it's asking me to solve for the diameter. So in order to solve for the diameter and get the pi symbol away from me, you have to divide by pi. Which means these cancel. Which means that 25 over pi is the value of the diameter. Okay. So that was circumference. Now this is arc length. So arc length just means that we want just a small portion of the circumference. Okay, so in order to do that, we're going to use the equation of arc length of AB is equal to the measure of AB, or the measure of the central angle, otherwise known as theta. Okay, that's a Greek letter, over 360. All right, this portion, this is the measure of AB, okay, which gives me the value from here to here. This is going to tell you how much of that circle you want. All right, this is the entire circumference, but this portion here is going to give you how much of it you actually want to see. Okay, so the actual equation again is arc AB is equal to the measure of arc AB in degrees, okay, over 360 times 2 times pi times r. So here, we're going to work with that equation. Number one. Let me zoom out a little bit. I'm trying to give ourselves some room here. We'll cover up the word examples, because you know these are examples. So with number one, I'm going to again have the equation. So AB is equal to the measure of AB over 360 times 2 pi r. Okay. We'll notice that the value of the measure of AB again is the central angle. So that is 35 degrees here. Okay, it's right there. So AB is equal to 35 over 360 times, and since this is a fraction, I'm going to make this a fraction as well. This is 2 pi times the radius, which is given as 12, and put that over 1. Okay, and then I'm going to start simplifying. So here you have options again as far as how to simplify. All of you are going to do this differently. You can take 35 times 2 times 12, write that answer, and then divide it by 360 and give me a reduced fraction. Or we can just start simplifying things. So here I'm going to write 35 times 2 times 12 over 360. And I'm just going to move the pi symbol over here. Okay. And then I'm just going to start reducing it bit by bit. So here I'm going to take this and I'm going to divide by 2 up top and on the bottom. Okay, which is going to give me then the value of 35 times 12, because again I'm getting rid of that 2, I'm dividing it by top and bottom, which gives me 180 on the bottom. Pi. And then I'm going to divide the top and bottom by 12, because 12 goes into 180, which is going to give me then 35 over 15 times pi. Okay. And 35 and 15, I can divide both of them by 5. When I divide both of them by 5, that gives me 7 over 3 pi. Okay. Again, you could have just multiplied through. Take 35 times that 2 times that 12, you would end up with a rather large number, okay, divided by 360, and then in your calculator you can reduce that for yourself, okay? Or you can do like I did here and just do it step by step, right? From here, we divided this and this by 2, okay, which left me the 35 and the 12, and half of 360 was 180. And then I divided 180 and 12 by 12, that gave me this. And then I can continue to divide by 5 on top and bottom and reduce. For number 2, again, same equation here. I'm going to have AB is going to equal the measure of AB over 360 times 2 pi r. Okay, and again, I know it's kind of tedious work to rewrite the same equation over and over and over. However, I strongly encourage most of you to continue to write it over and over and over, because if you do, it helps instill it and ingrain it in your brain. Okay, you can't forget it. When we plug in the values that we know, the measure of AB here was again that central angle. So AB, let's do this in alternating colors, was equal to that 120 over 360 times, and again I'm going to make this a fraction, 2 pi times the 20 over 1. I'm going to go ahead and again shift them around here so that I have all the numbers next to each other. So AB is equal to 120 times 2 times 20 over 360. Don't forget your pi. I'm going to look at the fact that 120 and 360 I can divide nicely, right? So AB is equal to 2 times 20 over 3. Again, not forgetting our pi, because 120 divided by 120 is 1. 360 divided by 120 is 3. And then if I take 20 times 2, I get the answer of AB is equal to 40 over 3 pi, which is as reduced as we can get. Okay. Again, something like this, I would not be okay with a decimal answer, because 0.3 does not stop, or 0.6, depending on what value we have with the third. Okay, so do not leave that as a decimal. Leave it as an improper or a mixed number. Okay, last 2 examples for this section, and then it's all you. Again, pay attention to what it's asking for. So here for number 3, it is asking me to find the circumference of circle T, which means it's already given me the arc length here. Okay, but again, the equation was arc length of AB was equal to the measure of AB over 360 times 2 pi r. However, here again, I'm looking for the circumference. And if I pay attention to the equation, this portion right here is equal to the circumference. So my suggestion is, again, to take and look at some of these equations that you're given and be able to alter them or modify them, okay, so that they can work out for you. So here, let's say that now AB is the measure of 360, sorry, the measure of AB over 360 times, instead of 2 pi r, let's just put C for circumference. Okay, we know the piece for the measure of AB. We know the piece for the AB length. So we just plug them values in. The length of AB here is that 45. Measure of AB is at 85. That's times C. Okay, and when you have something times a fraction, we then have 2 options. I can divide both sides by that fraction, Or what we will do here is I'm going to multiply by the reciprocal. So I'm going to take this fraction here on C, and I'm going to multiply both sides by its reciprocal, which means I'm just going to flip it. Okay, and again, I'm going to do that on both sides. And what happens here on the right side, this would cancel the 360, this would cancel the 85, which leaves me just that value of C here. Okay, this 45 I'm going to make into a fraction. This is 45 over 1. Okay, and when I do that, then I'm going to again just rewrite it. I have 45 times 360 over that 85. Okay, and again, then simplifying like I did in the last slide, I'll put C over on this side now. I'm going to do 85 and 45. I'm going to divide both of those by 5. When I do that, that's going to give me 9. Horrible 9. 9 times 360 over 17. And then I'm going to take 9 times 360, and that gives me 3,240 over 17. Okay, and you'll find if you plug that into a calculator, that is the simplified fraction. Okay, and again, I don't want a decimal that just continues on forever. I don't want you to chop anything off and drop off decimal values. Put as best as you can. Okay. Number 4 here, I'm finding the measure of AB now. So again, I'm using this equation, okay? But I'm going to again modify it a little bit, or am I? Okay, so I know certain pieces here. I do know the value of AB here. That's that 36 feet. Okay, and again, the length will be in some measurement that we know: inches, centimeters, feet, yards, etc. Okay. The measure of AB is in degrees. All right, so we have to find this. But we know the radius. The radius here is 12. Okay, so again, I'm just going to plug in. I have AB is equal to the measure of AB over 360 times 2 pi r. Again, just plugging in things that I know. 36 is equal to, we don't know measure of AB, over 360 times, and again I'm going to make this into a fraction, so it's 2 pi times the 12 over 1. Okay, and again I'm just going to shift some things around here. So this is 36 equals, I'm going to do the 2 pi and the 12 over 36, because it's 360, because 360 times 1. And then I'm going to put the measure of AB next to it. Okay, so I'm shifting the things around that I'm going to have to move away from the AB, the measure of AB. Okay, and again, I'm just going to reduce things. So I have the 2 that would go into 360, or I have the 12 that would go into 360. And again, your choice is up to you. Okay, you pick which one to do. I'm going to reduce by using, let's do the 12. Okay, so 36 equals, if I take 12 and 360, that leaves me the 2 pi, and that gives me what? 12 goes into 36 3 times, so that would be 30. And I still have that measure of AB. Okay, and then what can happen here, the 2 and the 30 then reduce as well. So I still have that 36 on the left. 2 and 30 becomes now 1 and 15, so I have pi over 15 times the measure of AB. And again, now I'm in a situation where I'm something similar to what I did here. I have a fraction that I need to get rid of. I can divide both sides by that fraction, or again, I can multiply both sides by the reciprocal of that fraction. So I'm going to multiply by this flipped, or 15 over pi. And again, what happens here is the pi's will cancel out there. The 15s will cancel out there because there's one on top and one on bottom, or one in the numerator, one in the denominator. I'm going to make this into a fraction, so it's 36 over 1, and multiply across. Okay, so 15 times 36 is 540. Pi times 1 is pi, and that is the measure of AB. Okay, again, that looks a little weird compared to, let's say, 85 degrees. However, again, I want to leave pi in these and leave it as simplistic as possible. Okay. Again, if you have any questions, comments, or concerns, please feel free to reach out to me and let me know.